Hi, I am Iqbal Imam from Aligarh Muslim University, Aligarh. My specialization is ecology and remote sensing and GIS. The model which we are going to discuss is GIS modeling. After covering this model, we will be able to learn about the concept of modeling, different type of GIS modeling, how GIS modeling can be developed, and what are the softwares which can be used to develop the GIS modeling. So, what is modeling? Modeling is the presentation of complex phenomena into a very simple concept. The model can be presented in physical form, in graphical form, in mathematical form, and in a symbol form. While developing the GIS model or model, we should keep certain things in our mind. The model should be very easy and understandable by a layman also. The model can help in taking the decision by interpolating the information. The GIS model may be helpful in, or it may help in predicting the events on the basis of past observation. A model may be a structural model or it may be relational model. A model may be a structural model or relational model. A structural model deals with the structure and composition of the model, whereas a relational model deals with the relationship or relation among different variables that may be independent. Then come to the GIS modeling. The modeling which are used in remote sensing and GIS is known as GIS modeling. Like model, GIS modeling is having two major elements. These are the element one is the different variables, and these variables may be independent or dependent. The second thing is the relationship among different variables. With the advancement in model, GIS modeling is widely used in world as well as in India. The different models used in GIS modeling are binary model, index model, regression model, and process model. Come to the binary model. In binary model, the queries are based on yes and no. 1 is used for yes and 0 is used for no. For example, this technique can be used for raster as well as vector. Take the example of raster. There are two images having different information. Both images are overlaid and the information collected from both information are collectively taken. Come to the index model. Index model is based on the weightage derived from the analytical hierarchy process. Here different variables, independent as well as dependent variables are used, and according to its importance weightage are given. These weightage are relative weightage, and a matrix can be developed among these variables. Generally, Sati method is used, what we call it as a AHP, where weightage from 1 to 9 is allotted to different variables according to its importance. One may be low weight for a variable, whereas 9 may be very high. 4 and 5 can be considered as the mid weightage of the variables. Index model is also used for the development of HSI model, for example, habitat suitability index modeling. In wildlife, it is widely used to develop a model to evaluate the suitable habitat for a particular wild animal. For example, if you want to develop a suitable habitat for tiger, you have to consider various things. This may include independent variables as well as dependent variables, and the information collected from topography and satellite imagery, for example. From topographic map, data is collected on road network, distance from village, distance from water body, and contour is extracted to develop the dam. Later on, dam is used to develop the aspect and elevation. Satellite imageries are used to extract the information to make land use land cover map, forest density map, as well as to develop the threats or disturbance on the area. These all variables are pulled together and relative weightage are given according to its importance with reference to tiger distribution. For this type of index development, the researcher should be well known to the area. It must have the experience of tiger behavior, its movement behavior, and he should know the habitats preferred by a tiger, the food preferred by a tiger. Apart from that, he must have surveyed various literature on tiger distribution or habitat preference. These all experience are used to allot the weight to a particular variables. After allotting weight to all variables, a matrix is developed and comparative weightage are derived. Then all layers developed from topographic map and satellite imageries, they are pulled to remote sensing and GIS software like ADAS or Arcmap, where all layers are overlaid and each layer is multiplied by the comparative weightage. The final product will be in the form of a map which may give an idea about the suitable habitat of tiger. The suitable habitat can be re-scaled into most suitable, medium suitable, and least suitable or not suitable, like that. So, in this way, index model is used to develop the habitat suitability index for tiger using AHP, analytical hierarchy process. Now come to the regression model. Regression is widely used for developing modeling in GIS. In regression, the unknown values can be derived from the known values. So, it is an interrelationship between dependent variables and independent variables. Regression model can be of two types, linear regression and logistic regression. Here we will discuss about logistic regression, which is widely used to develop habitat suitability index. In wildlife, using logistic regression to develop habitat suitability index has become very popular, and you can say that relatively it is a very new technique. While developing model using logistic regression, we have to consider independent variables and dependent variables. Independent variables may be the environmental variables, whereas the dependent variables are considered to be the animal of what we are going to develop the habitat suitability index. To develop the habitat suitability index using logistic regression, we have to consider or we have to take variables from topographic map and satellite imagery, plus we have to see the presence absence of particular animals in their habitat. From topographic map, different layers in the form of map is derived. Contour is taken to develop the DEM, and from DEM we can develop aspects, elevation. Whereas road network, human settlement and different watersheds are extracted. For all these information collected from topography, a map is derived. We consider these variables because all are having impact on the distribution of the tiger or their habitat. We also have to consider forest types and forest density. Forest types and forest density can be extracted from satellite imagery. Forest type or land use land cover can be derived by using a classification techniques, and that classification may be supervised or unsupervised. The example what we are going to discuss is based, the classification is based on supervised classification. Whereas ground density of forest is derived from satellite imagery using the NDVI techniques. As you know that NDVI techniques is a type of classification where forest and non-forest are classified in a continuous manner. Later on, a category is allotted to the NDVI map. 0 to 10 means 0 to 10 scrubland, 10 to 40 less dense forest, 40 to 60 medium dense forest, and above 70 is dense forest. While categorizing or developing the LC map, we have to classify the area in different practices or land uses. Then a disturbance matrix or index disturbance, then a disturbance index is also developed by using land use land cover map. All these variables are pulled together and they are georeferenced in a very similar manner. For example, if we are using list 3, then we have to reorganize them or rescale them on 23.5 pixel size. Means we have to rescale them on a similar manner or a similar pattern. Then a field study is done to do the ground truthing as well as to collect information on the animals distribution. In logistic regression, present absence data was collected on animals or on animal. For example, here we have taken the gaur and we wanted to develop habitat suitability index for gaur in Chandoli National Park located in Maharashtra. We have considered the presence and absence of gaur at a particular location. The location was marked with the GPS and later on it is allotted to the GIS environment, in the GIS environment. More than 300 presence absence locations were collected while doing the survey of the area, and all these presence absence location were integrated with different or various variables developed in the form of map. After intersection with all variables, a coefficient is derived for a particular variable or map. These coefficients are used as a weight and it is multiplied by each variable. To do all these activity or process, remote sensing and GIS software like ADAS and ArcGIS is needed. All maps are pulled together in the environment of remote sensing and GIS in our remote sensing and GIS module. After that, model is run. A product in the form of map is the output is in the form of a map. This map is re-scaled after considering your field experience and re-scaled into most suitable area for GOR, medium suitable area for GOR, least suitable area for GOR and not suitable area for GOR. In that way, logistic regression is very helpful in developing habitat suitability index, and it is a very important example of geospatial technology to develop a habitat suitability index. Now come to another GIS model, what we call it as a process model. Process model is based on problem solving model, which is done on the hit and trial method. Next generation of geographic information system will be driven by process models. These are usually composed of algorithm and hierarchies problem solving techniques by trial and error method that will act on users' request for the GIS to perform some services for them. For this, it is connected to digital network to contextualize those requests and interact seamlessly with other databases and process to achieve users' goal. Process models are used for following main purposes: estimation, prediction, calibration, optimization. So, what is estimation? The goal of estimation is to determine the value of the regression function for a particular combination of the values of the predictor variables. Regression function values can be estimated for any combination of predictor variable values, including values for which no data have been measured or observed. Function values estimated for points within the observed space for predictor variables values are sometimes called interpolation. Estimation of regression function values for points outside the observed space for predictor variables are called extrapolation. Prediction. The goal of prediction is to determine values of a new observation of the response variable. It also determines values of all future observation of the response variable. Prediction can be made for any combination of predictor variables values, including values for which no data have been observed. Calibration. The goal of calibration is to quantitatively relate measurements made using one measurement system to those of another measurement system. This is done so that measurements can be compared in common units or to tie results from a relative measurements method to absolute unit. Optimization. Optimization is performed to determine the values of process inputs that should be used to obtain the desired process output. Typical optimization goals might be to maximize the yield of a process to minimize the processing time required to fabricate a product. Process modeling can be understood with an example. The present example is from the soil and water assessment tool, what we call it SWAT. The soil and water assessment tool is a specially referenced watershed model used to simulate the impacts of land use, land management and climate on water quantity or quality. This graphic illustration the general process associated with developing and applying SWAT models. The SWAT requires following information as input files and provides results in the form of output files as mentioned below. Inputs. Inputs are land management practices such as crop rotation, irrigation, fertilizer use, pesticide application rates, and physical characteristics of the basin and sub-basin, means precipitation, temperature, soil, vegetation, and topography. What will be the output? A number of output files are generated by SWOT. These files can be grouped by the type of data stored in the file. There are 4 output files generated in every SWOT. These files are the standard output files as denoted as .std, the hydrological response units, output files and sub-basin output files, and the main channels or reach output files. Other files that may be generated including pesticide summary files, stream water quality summary file, reservoir summary file, lake water quality summary file. Output data provides simulated water values of surface water flow, groundwater flow, crop growth, sediments, and chemical yields. Here you can understand it by the flow chart given as a water model process. You can see that in water model process, the first point is model setup, which is the data inputs. The second point is calibration, whereas third point is validation, and the fourth step is scenario analysis. Now come to learn that how modeling can be developed in Arcmap. As we know that a model contains only 3 things, that are elements, connectors, and text label. You can see the figure given below. So what is elements? Elements are the data and tools with whom we work. There are 2 types of model elements. The first one is tools and second one is the variable. Tools. Tool elements are represented with rectangle and are created when we add a tool from Arc toolbox. Variable. Variables are represented with ovals. It holds value that can be changed. There are 2 types of variables, data variables and value variables. Again, value variables are of 2 types, input value and derived value. Connectors. Connectors connect data and value of tools. The connector arrows show the direction processing. There are 4 types of connectors: data, environment, precondition, and feedback. Data connectors connect data and value variables to tools, whereas environment connectors connect a variable containing an environmental setting. When the tools is extended, it will use the environment setting. Precondition connectors connect variables to a tool. The tool will execute only after the connectors of the precondition variables are created. Feedback. Feedback connectors connect the output of a tool back into the same tool as input. Then come to the next thing, that is the text label. In addition to the variable tools and connectors model elements, there are text labels elements which are graphical elements of explanatory text in a model. Labels can be attached to elements or float freely in the model diagram. By this way, a model can be developed in Arcmap. Now we can conclude that GIS modeling is the presentation of complex phenomena in simple concept. It can be presented in graphical form, it can be presented in mathematical, or it can be presented in the form of sign. Before developing a model, we should keep in our mind that the model should be very clear, the irrelevant data should be eliminated, and its presentation should be understandable by a layman also. It may helpful in solving the problem by simulation. It may also predict the events on the basis of past experience. GIS modeling can be of different types. It may be binary modeling, it may be regression modeling, it may be index modeling, or it may be process modeling. However, In the development of wildlife, the habitat suitability index, the regression modeling or within regression modeling, logistic regression modeling is used widely, as well as index modeling is also used. When we are talking about the geospatial modeling, the modeling developed by index or AIHP, as well as modeling developed by logistic regression are becoming very important. By these modeling, we may identify the suitable habitats found in a particular national parks or forest area. It may be true for other things also. By that we can also identify suitable area for garbage dumping or suitable area for plantation or suitable area to develop in the form of industrial area. By modeling, by using the modeling, we may solve the daily life problem also. For example, the process modeling, it solves the problem. It is based on the hit and trial method, and the method which are very useful after testing may become as a model. Various forecasting can be also done by using modeling. The weather forecasting or the production of agriculture yield is also done on the basis of modeling. Modeling can also be used to identify the forest fire area, and on the basis of that measures can be taken. So what I am trying to say that model is very important, not only in identifying the problems, not only able to solve the problem, but also predict about the things which may happen later on. That's all about the GIS modeling module. Thanks.